Ever wondered how a capacitor, that tiny component in most electronic devices, works? Well, hold on to that thought because it's about to get demystified. Imagine a capacitor as a tiny, rechargeable battery in your electronic device. It has two metal plates separated by a non-conductive material, or dielectric. When connected to a power source, one plate accumulates positive charge, while the other accumulates negative charge. This builds up an electric field between the plates. The charge buildup process is known as charging the capacitor. But what happens when we disconnect the power source? Does the capacitor lose its charge? Interestingly, it doesn't. The capacitor holds onto its charge, waiting for an opportunity to release it. This is what differentiates capacitors from batteries. While batteries provide a steady flow of energy, capacitors store energy and release it in powerful bursts. This property is particularly useful in electronic devices that need quick bursts of energy, like the flash in your camera. You might be wondering, how does a capacitor release its charge? When the circuit closes, the electric field between the capacitor's plates forces the charges to move. The positive charges on one plate are attracted to the negative charges on the other plate. This movement of charges is what we commonly refer to as current. So, in essence, the capacitor discharges its energy into the circuit, providing that burst of power needed. To put it all together, a capacitor charges up by accumulating opposite charges on its plates when connected to a power source. It holds on to this charge even when the power source is disconnected. Upon closing the circuit, the built-up electric field forces the charges to move, creating a current. This is how a capacitor discharges its stored energy. In summary, a capacitor is an essential component in many electronic devices. It works by storing and releasing energy in quick bursts. It charges by accumulating opposite charges on its plates, and discharges by forcing these charges to move, thus creating a current. The capacitor's ability to provide these powerful energy bursts makes it a vital component in many of our everyday devices. So, the next time you snap a picture with your camera flash or listen to a beat drop in your favorite song, remember, it's the humble capacitor making it all possible. Who knew such a small component could hold such a significant charge, both literally and figuratively?